Hello, this video will cover ACT51 Science section. Okay, let's go to question number 1. Suppose the grocery store wants to purchase a variety of apple that will retain as much its initial firmness as possible when stored at 1 degree Celsius for 6 months based on table 1. So 6 months is 180 days. So what's the average firmness? Okay, it looks like the Fuji is highest, so then Fuji is the answer. According to table 2, study was initially average volatile abundance. Volatile abundance right here. 2 mg per liter less than, greater than this. Okay, red delicious. And equal to this one. Initially it says 2.7, so greater than. A student predict that duration of storage 1 degree Celsius increase 0 to 180 days. The average concentration of volatile compound, which is okay, increase. According to table 2, this prediction consistent data for varieties of apples. So this increase, okay, Fuji is good. Gala is not. And Granny Smith, yes. Red Delicious, no. So only Fuji and Granny Smith, yes. Number 4, based on table 2, which of the following graphs best shows the average volatile abundance of 4 variety apple storage time of 60 days? This one. 6.1, 6.1, this is 6.1, 6.1, and then 9.8, 9.8, 9.8, 1.2, okay, 1.2, this is not, so G. Number 5, based on table 1, which of the 4 varieties of apples showed greatest change? Firmness between 60 to 100, between this greatest change. This one's 12, 8, 14, 10. So 14, which is Granny Smith. Consider the statement among 4 varieties of apple tested, variety that initially had the least average firmness was also the variety that had the greatest change. Volatile abundances, okay? The data table shows yes or no. The least change, least average firmness. Least average firmness is Granny Smith. And Granny Smith is this 1.0, but it increase greatest average volatile abundance. Still least, right? So it's no. Average volatile at the end, 180 days. Abundance looks like in Fuji is the most abundant. So it's supposed to be no. Yeah, J. And then question number 7, according to figure 3, distance that material moved at site 5 was greatest between which of the following dates? Figure 3. This is site 3. Or site 5, this is site 5, greatest between. This is greatest. The steepest. So March 1st to September 1st. March 1st 98. September 1st, 98. So D. Which of the following statements best explains why precipitation data were collected along with the cumulative distance data? Precipitation data were collected along with. Then we have to read through. It says the scientists measured cumulative distance that material at the surface had moved since this show result, and then show the amount of precipitation fell at over 6. Okay. Probably water and, if you think about figure 1, soil creep material at closed surface move faster than deeper material, and block glide. The entire block material move approximately the same speed. Okay. So, because the water itself is pushing things down so that, you have more chance to, having cumulative, the distance will, you can see that, because of water, it actually travel more. So let's see which one. Water runs off surface, runs off surface, decrease, not stop, no, increase is right. According to figure 3, following graphs shows cumulative distance to material moves site 4 to 6 March 1st, 1996, March. This one. So around 8, 20, 20, 25, 8, 20, 8, 20, no. This is 8, 56 March. Oh, site 4. Oh yeah, site 4 is diamond. This is opposite. This would be 25, 28. 25, 28, which is B. Okay, consider in figure 2 the 6-month period during which no soil creep at any site of 1 through 3. During those periods, the amount of precipitation that fell at each of the site was. So, cumulative distance material moved, and precipitation is here. And then this is precipitation. Okay. And then it says no soil creep, which is it doesn't move at all. The case of this one, right? It's flat. So then we see that precipitation is lower than 200. So this is precipitation, right? It's lower than 200. Okay. 11. Suppose that site 2 scientists and also measure every 6-month cumulative distance that material at a depth 2 meters below surface had moved since September 1st, based on figure 1 and 2, March 1st, 1998. Measure cumulative distance less than or greater than this. Okay, March 1st, site 2, March 1st, 1998 is this one. Site 2 is circle 1, so this one. That's 0.8. Is it a little bit less than 0.8? Yeah, this is 0.8. But then now this is like in a surface one. So then if it is depth of 2, then if you think about common sense, if it is deep down, that probably like it travels less, right? So it has to be less than 8.8. I mean, slower. Yeah. So it's B. 12. According to figure 2 and 3, or the study period, was the cumulative distance that material moved due to soil creep less than or greater than the cumulative distance that material moved due to block glide? Okay. It says G. Yeah. Material moved as much as 1.4 due to soil creep. Because if you see 1.4 is this one, right? And then 64 is this one. That's what we're talking about here. And then because of that, you know, what to say is G. Okay. That's like steepest, the change that we see here. This is steepest. That's steepest too. That overall. Okay, move on to the next passage. 13. According to the result of experiment 2, soaking chickpeas distilled H2O for what length of time and what temperature result greatest absorption? Greatest soaking time. Greatest is this one. Okay, so 270 and 50. 2.0 NaCl solution tested experiment 3. CMU at 90 minutes. CMU 90 minutes would likely have been between 0.25 to 0.32. So maybe this one, 90 minutes most likely. Yeah. There's 2, which is between these 2. Okay. Yeah. Yeah. And 15, suppose the procedure, experiment 1 is repeated at temperature 15 degrees Celsius. Result experiment 1 and 2, soaking time 15 degrees. Here, soaking time is 120. Okay. So it has to be between, so these two are not. 120. So 15 is right in the middle. If you add it up and divide by 2, 80, 90, 93 divided by 2, 46. So it's supposed to be C. Okay. Yeah. And then consider a group of chickpeas in experiment 1 were soaked distilled HO2O 60 minutes. The chickpea not being petted dry after in the H2O, which would they CMU more likely have been greater than less than value table 1 soaking from 60. Okay. Soaking time 60 is 0.31. Soaking time 60. Similar. Let me just read this. Average final mass per chickpea is final mass. Obviously, if you not petted the moisture, so then it's still going to hold more. So the CMR is going to be greater because it's F, right? And then upon complete experiment 1, how many chickpeas had not been removed from distilled? Had not been removed. Experiment 1. Sample 50 dried chickpea size. Every chickpea. Okay, 5 chickpeas removed. Edit. Another 5. 6 different time. Therefore, another 5 removed. So which means 5 and then 6 times 5, 30. So 35 removed altogether. So 15 left. 18. Consider results experiment 1 and 3 at any given soaking time to compare with CMU of chickpea soaked in distilled water and CMU of chickpea soaked in NaCl solution. CMU. The water is always less. If you look at the CMUs, always less. Consider CMR of any group soaked chickpeas in experiment 1. Also consider CMI of the simple dried chickpea experiment 1 was CMF greater than, less than, or equal to CMI. So if you think about this graph itself, and also CMF, not CMR, CMF is final mass and CMI is initial mass. So obviously it has to be greater because you're dealing with, you soak the chickpea in the water or any solution, and then final result has to be greater because they soak, they actually take the moisture, so then the mass has to be greater. So it's A. Move on to 20. Suppose that there had been no prothymol glue in solution placed in the tube. Which of the following pieces of equipment would have best allowed the students to determine if the concentration of CO2 dissolved in solution changed during 24 hours incubation? I don't know what's going on, so I have to read through a little bit. Carbon dioxide is consumed more photosynthesis and produced during the cellular respiration. Photosynthesis is okay. This is photosynthesis. Gonna dissolve CO2 dissolved solution, concentration dissolved solution. Determine how the pH of aqueous solution is affected by the additional solution of organism that is undergoing this. So it has to be pH level then. Right? That's what it is here. And then 21, at the end of 24-hour incubation, pH of solution tube 1 was closest, which are the following. Tube 1, green. So green is 6 to 7.6, so 7 is only 22 conditions for tube 3 and 5 differ in which of the following ways? Tube 3, tube 3 and 5, no, 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 yes, so this is difference. Snail presence is the one that we see, and then also light is darker or light, darker or light. Okay. Snail, dark, so tube 3 is dark. This is wrong, wrong. Contained organism that overflow 5 contained organisms. Okay. Eulodia presence and snail presence is something that we have to like compare to, because 3, yes, for Eulodia, but then here I did a piece of Eulodia, snail, both each, like blah blah blah. Okay, so it's not only like dark or not a light treatment. It's more about what kind of like organism that we actually put into. So Eulodia is a water plant, right? So then whether you okay, so like tube 3 is water plant, yes, snail, no, but then 5 is no water plant, yes, snail. So then if you think about organism, autotroph, so it's H, obviously. Autotroph is the Eulodia, the plant. Heterotroph is obviously the snail. So auto means self. So troph is, you can just think it as by itself. You can do the what is it called, the photosynthesis. So like obviously plant itself is the one that it can do like photosynthesis. That's why it has to be like the plant is yeah, plant itself is autotroph. Okay, 23, the student had hypothesized that in absence of photosynthesis and cellular respiration, light would break down the promethyl blue in the solution during the 24 hours incubation, causing solution to become yellow, the result explained. Okay, so you see that whatever tubes that the dark or light, but then the whatever result is yellow, that we just see yellow, 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 yellow. Okay, so if you look at the answer choice, this is like comparing tube 2 and tube 5. So if you see tube 2 light and tube 5 is dark. Light but green, dark, yellow. So obviously this is no, because it is the light, this is C, because tube 2 is green, because like the even with the light, it's green. So the hypothesis saying that the light would break down the promethyl blue so that it's going to be yellow, but then even though it has a light, but then it became green instead of yellow. That's why we can find it. And 24, at the end of 24 hours incubation, Y was color of bromothymol blue solution of in tube 7 different color, tube 8 absence of light 8 Elodia, tube 7 not undergo. Okay, tube 7 and 8, yellow and green. So yes and yes, dark. Okay. If it is Elodia, yes, but then dark, 7 not undergo photosynthesis because, okay, photosynthesis causing. Okay, so it's F because it has, you have to have whatever, the 7 is dark, so we have light energy, but then the whatever Elodia itself consuming this CO2 so that you cannot, make this one. Okay, so that's why it is F. So consume less CO2, Elodia. Okay. Okay. And then 25, the end of 24-hour incubation, student removed the snail from tube 6 and added 10 drops of new solution, causing color of bromothymol blue solution, and the turn changed to blue. Tube to change to blue. What was new solution more likely, acidic or basic? So blue is greater than 7.6, which is basic. Acidic is lower, lower, a smaller number, so basic because it increase. See. Suppose the additional tube 9 had been included in the experiment, and that tube 9 contained small fish, but no Elodia or snail received light treatment. Okay, light there. At the end of 24 hours. Okay, so it's like basically no, yes. So no, yes is this one, similar to 2. So it says contains small fish. Okay, no, sorry, this is not it. No, yes, no, yes, yes. So 6, it's like similar to 6. Yellow, yeah. Fish is the one that consumes CO2. Produce CO2, I'm sorry. The plant is consuming. Okay, move on to next one. According to the result of experiment 1, as data increased, tension cable 2, experiment 1, data increased, tension cable 2, also decreased. This is decreased. And then based on the results of experiment 1 and 2, which the following expression always equal to 0. Same number you have to find. These 2 are equal to each other, right? 9, yeah. And these 2 also equal to each other. So if they add it up, it's going to be 0. Add it up, 0. Okay. Suppose that cable 2 attached L-shaped support using a bracket that has maximum tension rating 51 N. Based on the results of experiments, it's safe to use this bracket. Any tension is greater than 51 is this one, trial one. So it's not. Right. So it's no. T2 you said. Trial one, T2, yeah, we exceed this. Based on the result of experiment 1, in order to absolute value T1x to be equal to T1y, what angle should cable 1 top of support? T1x, T1 equal to each other. It's like near this, but then a little bit above. So it's like between 30 and 50. Between 30 and 50 is only at. Suppose that experiment 2, a trial had been performed in which T1y was 68.6. The mass of the cylinder, the trial most likely have been, okay, mass of cylinder, what should think about mass itself. Okay, mass is this one. And then it says 68.6. 68.6 is getting like here, greater. So it has to be more than 6. More than 6. Okay. It has to be more here. Every time you increase 1, it increases about 8 or yeah, 8, 9. 8, 9. So that if it is 7, 8, 9, so 8. It's around 8 then. So between, yes, this one B. You can simply calculate that, through the whatever. Which of the following statements about data or M summarize important difference between two experiments? In experiment 1, data independent, dependent, M. Okay, so experiment 1, data is independent because as you put in different data, different thing that we see, and then experiment 2, data is just stays same because data is 50, and then experiment 2, M is the independent, but then data stays same. Okay. Data independent variable where experiment 2, the whole the constant. Yeah, that's good. Independent, data dependent, no. Independent variable, M is not a constant. This one, okay, M is 112 kilogram. Okay, so it's F because H is opposite. If it is saying that the question says experiment 2, M was independent, and then experiment 1, M was held constant. So it's like opposite. Vector quantity such tension written A, X, Y, By. A is vector horizontal, B is vertical. Experiment tension, cable 1 during experiment at trial 1, written this one. Okay, cable 2, trial 1. So trial 1, 2 is this one. Oops, this 2. So the first one goes X, right? So the second one goes y. So you can think it as 55.6 minus, okay, wait, 0. 0 is tension 3. Let me just read this to figure. T2 is, yeah, going to this direction. That's good. And T3 is, this is gravity basically. It doesn't pull it down. Because 9.8 is the gravity. So it's supposed to be 0 then. It is this is a trick question. Okay, so this is not like, something that you're pulling it down. So just naturally, like, gravity or whatever. So this one, scientists want to, the question we need to read through. So basically, you need to know what's the difference between scientist 1 and 2. So okay, area Mars, the winding channels regional, the sum of the 100 kilometer long, formed more than 3 billion years. Scientists discuss whether these channels formed liquid H2O by liquid CO2. Unlike today, Mars were warm enough for this liquid CO2 to exist. Okay. So that's why liquid CO2 released suddenly from the basin, rapid learning around the soil. Okay. Form the channels. Okay, they have enough of liquid water, that's why outflow channels, just like washed off. And then gray hematite is abundant with mineral absorbed exclusively with liquid. Okay, that's why. So this mineral actually absorbed everything about this, and then like quantity was still present. Okay. Scientist 2, before the large CO2 gas was present. Okay, and then rock soil enough change CO2 to liquid. And then later major events such as asteroid impact removed most of overlying material. Liquid CO2 quickly moved up, then along the surface. Then rapid flowing liquid CO2 carried away rocks and soil, forming channels. Okay. That's the thing. Liquid. That's what they call pyroclastic flows. And temperature never been greater than this, so it's always cold. That's why CO2 frozen. Okay. Both scientists formed channels a billion years ago. Erosion, volcanoes, erosion. The one is by water, one is by CO2, liquid CO2. And a student study conclude that the all time before 3 billion years ago, temperature, present conditions, short distance below, okay, have not allowed liquid CO2 to exist. This is inconsistent with scientist 2, because scientist 2 saying that, liquid CO2, and then it's not allowed liquid CO2. Consider scientist 1 and scientist 2 assertion about source of liquid formed channel. Scientist 1 is on the surface, and then 2 is gas price below the surface right here, so it's supposed to be G. And then 1 is, it says on the surface, the percentage of each. 37 studies have shown that prior to 3 billion years, light CO2, once it reached Mars' surface, a liquid CO2 would be evaporated completely before it flowed 2 kilometers. Does information support weakened sensitive? Weakened because it doesn't make that, the channel then, because 2 kilometers is long enough, because the channel itself is 100 kilometers long. So let me see. We can stick with at least is so yeah. So the discovery of which of the following features in the Planitia made today would provide best support scientist twos. Scientist two means thick frozen layers, tubular layers, mountain impact crater. So let me see. The asteroid, yeah, this is the one. Asteroid impact. Okay, that's crater then. Suppose the liquid H2O was present Mars surface 3 billion years ago. So which is scientist one? Yes. Yes. Scientist two, Mars surface. Yes, two. So it's A. Because carbonated rock, which is CO2, is the one that, you know, it says carbonated rock right here. Carbonate rock. Based on scientist two discussion that the pressure of rock, soil on subsurface CO2 have effect of increasing the average distance between CO2 molecules or of decreasing the average distance between CO2 molecules. Okay. It says that, you know, here soil became great enough to change CO2 to liquid, right? So that pressure changed to gas to liquid. That means distance between molecules. If you think about gas molecule is much like spread out. That's why the volume is greater. So it got decreased because it changed to liquid. So it's a J. Okay, that's it. I'll come back with other tests as well. We'll see you soon. Bye-bye.